Hi everyone, and welcome to Containers One-on-One Online Meetup. In today's meetup, we will continue demonstrating how to build a microservice using Node.js and Docker. In the previous meetup, we have learned about the basic Docker command such as Docker search, Docker pull, Docker run, and we have predominantly created Docker image using the Docker commit command. In today's meetup, we will learn more about Dockerfiles, how to write Dockerfiles, what are the Dockerfile commands, how the caching mechanism of Docker works, and also how we can optimize the Docker building process. For those who this is the first time attending this meetup is a series of 30 minutes webinar plus 10 minutes for question and answer in the end. The meetup is mainly hands-on and live demo. We do have some slides to just set the context, and all the sessions are recorded, and we will be sending the recording after the meetup. We also encourage you to suggest a topic for the future meetups. Also, you can position yourself as speaker for the future meetups, and you can do all of that on the meetup discussion board. Few words about myself. So my name is Raziel Tabib. I'm a developer, entrepreneur, and I'm passionate about new technology. I live here in the Bay Area since 2008, but I'm originally from Israel. I'm also the founder and the CEO of CodeFresh, which is sponsoring this meetup. You can follow me on Raziel Tabib on Twitter. Few words about CodeFresh. So in CodeFresh, we build a Docker platform for dev team. Basically, it offers a Docker-based continuous integration that not only run your test, but also create a Docker image that you can either spin up locally or spin up on our hosted environment. So you can create testing and staging environment basically on any branch or pull request or commit. You can follow CodeFresh on @CodeFresh on Twitter. So terminology, we will be using these terms pretty intensively today. So Dockerfile, which is basically can be perceived as a recipe for Docker image. Docker images are the blueprints of our applications, while Docker containers are actually live instances of this Docker image. Docker daemon, this is what is doing the heavy lifting of building and running Docker containers. And Docker client, this is what we have locally on our machine that connects to the Docker daemon and pass the commands to the Docker daemon. Docker Hub, this is a registry of Docker images. You may either use Docker Hub to store and pull your images, or you can use a private registry. We also recommend going up to this blog here. You have the link at the bottom here, and there is a very good descriptions there of the Docker basics. So to recap what we did last time, and again, the recording is available on vimeo.com/codefresh. We have started by running an instance, a Docker container of Ubuntu that we created from the Ubuntu image. And then inside this container, we have manually installed Node.js. After we install Node.js and we've seen that everything is working properly, we've in fact stepped out of this container and we used the Docker commit command to create a Docker image that includes Ubuntu and the Node.js installation. Then we've created locally a simple Node.js microservice, and following that we have again created an instance, a container out of the base image, but this time we copied our microservice into this container. We have run npm install, npm start. We have checked that our microservice is running well on this container, and we stepped out of this container, and using Docker commit, we have created a new image that includes a microservice, Node.js, and Ubuntu. As the last step, we have taken our image and we have pushed it and published it in Docker Hub. So this is what we did last time. What we will be doing today is we will use Dockerfile and Docker build command. We will write first a very basic Dockerfile that when we pass it to the Docker daemon, it will create the base image that include Ubuntu and Node.js. As we're doing it, we will learn about the different Dockerfile commands. We will talk about the caching mechanism of Docker, and then we will create a simple microservice, and we will update the Dockerfile now to create an image that includes our microservice in it. Then in the last step, and if time will allow, we'll actually see how we can move an image from one host to the other, in this case from our local host to a remote host in DigitalOcean. Okay, one last comment before we start. In the previous meetup, we have in fact used Docker version 1.7, and we used boot to Docker. There was a great progress since then, and Docker have released Docker version 1.81 and also released the Docker toolbox, which is now available on docker.com/toolbox. It's very convenient. When you download and install the Docker toolbox, you get Docker 1.81, you get Docker Compose, Docker Machine, and Swarm, and boot to Docker is now deprecated. So in this meetup, we will be using the new Docker toolbox. And by the way, there is an online meetup tomorrow from Docker in which they will be talking in depth about the Docker toolbox. Okay, let's jump to the console. Okay, here in the console, let's first start and see what we have installed. So I run Docker -v, and we run in Docker version 1.81. Let's see which host we have installed. So we do Docker machine ls, and we can see that we have 3 hosts. In today's meetup, we will use the Meetup host, which is local. You can see that the driver is VirtualBox. Okay, then let's see which images we have on our host. So we run Docker images, and we can basically see that there is no image at the moment, so we're starting pretty fresh. Okay, so let's start with the first step of writing our first Docker file. I'll use VI for it, so type VI, and then I'm intentionally naming this file Dockerfile. And the reason I do it is that when we run the Docker build command later on, if we don't specify any Dockerfile name, it will look for a file named Dockerfile. We can obviously name it in different names, but then we will have to specifically call out which file the daemon has to use in the Docker build command. Again, if we want to avoid it, if we just want to run Docker build without specifying a name, we call our Dockerfile Dockerfile. Okay, let's go in, and now let's write a first command, which is from, which indicates to the Docker daemon what is our base image, and in this case it's Ubuntu latest. It's also a good practice to specify who's the maintainer of this Dockerfile. In this case, it will be myself. And now we will run some basic commands that will install Node.js. I will breeze through it, and we will start the Docker build process, as it will take a few minutes. And then we will revisit every step that we did here, and I'll talk in more details about what is actually happening behind the scenes. Okay, so let's do run apt-get update, and then run apt-get install Node.js, Node.js legacy, and npm. That's it. Let's step out and let's start running the Docker build command. So we do Docker build. Again, we don't need to specify any Dockerfile file name because we named our file Dockerfile, but we do need to specify what is the name of the image that we want to create. So let's call it Node.js with the tag 0.1. Then the last argument we pass to the Docker build command is the context, and in this case let's use our local directory. Now when we run it, we see that the first thing that the client does, it's actually sending the context to the Docker daemon. Since the context is a local directory, it just had to send 9.2 kilobytes, which didn't take time, and it happened pretty fast. This is important things to know. If I would have run this command from my root directory, we would have been waiting here for a few minutes, if not more, for the Docker client to send all of my directory as the context for the Docker daemon, which is not needed. It's a good practice to send in the context only what is needed in order to build the Docker image, which is, in most cases, our source code repositories and maybe some additional files. Okay, as the Docker daemon building a Docker image, let's go back and revisit the Docker file that we wrote and talk a little bit about what is happening behind the scenes. So right, cut and Dockerfile. Okay, a Dockerfile is composed of command and argument. So from is a command, maintainer is a command, run is a command, and Ubuntu is the argument, Raziel at Codefresh.io is an argument, and so on. Every command results in a Docker image, which means a Docker image can be composed of other Docker images, which are layers. And in fact, the Docker daemon, for each and every command here, it will create a Docker image, which will be a layer in the Node.js image that we created. Now, one more thing that it's good to keep in mind. The way the caching mechanism works is that the Docker daemon, as it moves from one command to the other, it checks if it has this intermediate Docker image, if it has this layer already in the cache. If it doesn't have it, it will rebuild it. In fact, not only if it doesn't have it, if it doesn't have it or whether this layer has changed, it will rebuild it. If not, it will put it from the cache. Now, one more thing to keep in mind is that as the Docker daemon is moving from one step to the other, once it hits a layer that has to be rebuilt because this intermediate image is not in the cache or it has changed, then from then on it will rebuild each and every one of the following layers. So it can be it can work like this, like I can pull from cache, pull from cache, pull from cache, and then I hit a point when I cannot pull from cache and I have to rebuild this layer. From then on, every layer after will be rebuilt. Again, we will see a live example of how it works. So just keep that in mind, and we'll get back to it in a few minutes. Okay, let's go back and see the progress that we had with the Docker build, and we can in fact see that the Docker build process has been completed. So if we run Docker images, we can in fact see that we have the Ubuntu image, which is the base layer we used to create the Node.js image that includes the Node.js installation. First of all, let's see that we've in fact installed Node.js properly on our image. Let's do Docker run, and we'll run our Node.js image, and we run the command node -v. Okay, so we installed it properly. Now, as we said earlier, the daemon actually created and built additional images, which are the layers that the Node.js is composed of. And to see these images, we can run Docker images, but this time with the flag -a. In fact, we can see that there are additional images now in our host, and these images are the intermediate images that the Docker daemon created as it built the Node.js image. In fact, we can also run Docker history, and we do it for the Node.js 0.1, and we can see the images that were created for each and every command we had in our Dockerfile. Okay, so now we understand that how the Docker daemon intercept the Dockerfile and create these intermediate images, and then it create our final image that is composed of multiple layers. Now let's see this caching in action. Let's go back to our Dockerfile, and let's add one more command at the end. Let's do run apt-get clean. Okay, let's run the Docker build again. This time we'll change the tag to be 0.2. Sorry, Docker build 0.2. Okay, now when we run it, we can actually see that it took much faster because the Docker daemon used the cached intermediate images, and the only command that resulted in additional layer is the apt-get clean. So this is again an example of how the cache mechanism work and how it accelerates the Docker build process. Okay, now again we will see it in more details and in much more depth as we move to build an image of our microservice. So now let's start by creating a very simple Express microservice on my local drive, and we will use Express. We will name our microservice my microservice, and here we can actually see that a new directory with a microservice has been created. It's a good practice to keep the Dockerfile inside the repo, so let's move the Dockerfile to the directory, and now let's go to the directory. Okay, so now we in fact have the Dockerfile and the microservices all here. Let's update the Dockerfile to include the microservice inside an image. So let's do vi Dockerfile. Now intuitively, what we would do, and that's what typically we do, is we can run the copy command, and we can copy all the files in the context, which means all the repo, to a directory named source that we will create in the image. And then the next command will be run cd source, and then inside this directory run npm install. Now in fact this will work perfectly, and we can actually see it works in action. Let's do Docker build. Let's name it my microservice with the tag 0.1, and we'll pass the context of the current directory. And again, this will work. The npm install will be executed, and we will get an image that includes our microservice and the npm install. However, this is not an optimized way of constructing our Dockerfile. And let me explain to you exactly what we can actually improve as we're writing our Dockerfile. So now it's completed. In fact, if we run Docker images, we can see that we have here my microservice 0.1. But let's revisit the Dockerfile for a second. We have added an intermediate layer here which copies all the files that we have in a repo into the directory source. And then after that, we had another layer that is running npm install, which is a pretty heavy command. Now, each time we're going to make any change to our repository, whether we're modifying an existing file or adding file or deleting file, that will cause this layer of the copy to change, and it will cause this intermediate image to be rebuilt. And if this intermediate image will have to be rebuilt, Then the Docker daemon has to rebuild the npm install layer as well, and that is a costly layer to be created because npm install is a heavy command. It can take a few minutes, which in fact it's redundant because we don't need to run npm install after every change we make to our repo. We need to run npm install in most cases only if the package.json file has changed. So first of all, let's actually see in action why this way of constructing a Dockerfile is not an optimized way. Let's just add a simple file to our repository. We'll do touch test.txt, and now let's rerun the Docker build with the tag 0.2. We can in fact see that since the intermediate layer of copying all of our repository files to the directory source has changed, the Docker daemon has to rebuild that layer, and then it has to rerun npm install because it has to rerun all the following layers as well. Again, this caused the Docker build to actually be longer than it should because we don't need any additional npm module. Let's try to construct our and write our Dockerfile differently. Instead of creating here a layer that copies all of our files, let's just copy the package.json file, and then we'll run the npm install, and then after that we will copy, this time we will copy all of the files to the source directory. What is different in what we did now is that now this intermediate layer is going to change only if package.json has changed. So this intermediate Docker image can be pulled out from the cache unless the package.json file has changed. And only if the package.json has changed, it will rebuild that layer and it will rerun the npm install. If the package.json has not changed, it will pull this intermediate layer from the cache and it will pull the npm install from the cache, and it will make the whole building process much faster. And let's see that. So now, since we changed the Dockerfile, when we will run the Docker build again, in the first time, that will indeed run the npm install, and that might take, depends on how big is the repository, but it might take a minute or maybe a little bit less. But once this is complete, we will now test it again. We will add, now let's add another file to our repository. And now let's rebuild, but in fact when we rebuild our microservice now, we can see how fast this process was this time. And that because the copy, for the copy command of the package.json, it could use the cache, and also for the npm install, it could use the cache. It only the last copy command has to be rebuilt to include our new file in the final image. Okay. So this is how we can optimize, and again, it's good to keep that in mind, because if we keep that in mind while we're writing the Docker files, we can significantly improve the performance and optimize the build process. Now, let's complete writing our Docker file and create an image for our microservice. So we're going to go back to Dockerfile, and then we're going to add 2 more commands. The first one will be telling the daemon what is the working directory, and in this case you can tell it's working out of the source directory. And then we can specify what is the default command to be executed if we run a container of this image without specifying, without calling out a specific command. And for that we're going to use the command, and we're going to tell it it's going to be npm, and it's going to be start, and that's it. Now let's create a final version of our Docker image. It's going to be 5. We'll run it again. It happens so fast, and that's because it could have cached everything besides the last 2 commands that we added. Okay, let's run Docker images. We can see the latest image that we created. Let's run our microservice and see that it's actually installed properly. So we'll do Docker run. You can run it in the background. We will map the port 3000 of the host to 3000 of the application. And then the name of our image is my microservice 0.5. Again, we don't need to specify any command because we want it to take the default command. And now when we run it, we actually have the container running now. If we do docker ps, we can see we have the container running. If we want to access our service through the browser, let's find out which IP we can use. So for that, we can do docker machine IP and then Meetup, which is the host that we're using. This is the IP. Let me copy it. Let's open a browser. Port 3000. And here we have our service working. Okay, so we have our service working properly. Let's recap quickly what we did. What we basically did today so far is we have created a basic Docker file and we pass it to the Docker daemon in the Docker build command, and that will resulted in having a base image that include Ubuntu and Node.js. We then created a microservice and then updated Dockerfile to copy first the package JSON, run npm install, then copy all the rest of the repository, specifying what is the working directory, what is the default command, and that created an image that we can simply run with a docker run command. Now let's look a little bit about how we can move image from one host to the other. Let's go back to the command line. Let's clear it here, and let's see first of all which host I have here. So I have 3 hosts on my machine, 2 that are local. You can see VirtualBox, the default one, and the Meetup, and I have 1 that is remote, which is on DigitalOcean. First of all, Docker Machine made it very simple to connect to remote hosts on the various cloud provider, whether it's DigitalOcean, AWS, Google Cloud, and so on. If you want to add a host, if you want to add a host to your machine, you basically use the Docker machine create command. And then there are a few flags that you will be using. You know, the first one is -d, and then you tell it whether it's VirtualBox or Google or DigitalOcean and so on. I will just run it now with -help grep DigitalOcean so you can see an example. So in case of DigitalOcean, you will have to run it with -d DigitalOcean, then provide the DigitalOcean access token, and that's the way you can very fast connect to a host on DigitalOcean. You can do a very same thing for Google. So you can add it by providing your username and the project name and so on and so forth. Again, we might be covering that in more details and how to connect to a host in the future meetups. Now let's go back and see. Okay, so we have these 3 hosts, and basically we would like to move our image from the Meetup host to the DigitalOcean host so we can run it on DigitalOcean. Now the proper way to do it will be using a registry, which means we will push the image from one host to a registry, and then we will pull it from the remote host and we run it there. However, I often also using it, moving it from one host to the other, not with the registry when I want to play around with images. And basically I'm using the docker save and docker load command. Docker save is saving an image to a file, and docker load is loading an image from a file. However, if I run docker images here, we can actually see that the image that we created is pretty heavy. It's 375 megabytes, so that will take us a little bit to load it to DigitalOcean. So what I will do, I will actually pull a slimmer Docker image, and I will show you how I do it on a very slim and light Docker image, but it will basically work the same, just a longer time, on any other image. So let me do docker pull hello world. That is a very light image available in Docker Hub. So we can see that we've just pulled it. So if we do docker images, we can see the hello world image here, which is only 960 bytes. It's pretty light. So the way we do it is we run docker save. We specify the name of the file that we want to save this image to. So we call it hello.tar, and then the name of the image you want to save, which is hello world latest. Okay, so we run it, and then now when we run ls, we can actually see we have here hello.tar. That's the file to which we save the image. Now let's switch to the remote host of DigitalOcean. To do that, we will run the eval command, and then we do $docker machine and DigitalOcean. Okay, that will switch to the DigitalOcean host. We can run docker machine ls, and we can in fact see that yes, now we're working with the DigitalOcean host. We can run docker images here, and we can see that in fact we already have one image here, which is the image that I've pre-loaded to DigitalOcean, just to show how it's very easy to run containers on remote hosts, just as easy as I do it on my local host. But let's first start by loading the image that we saved into this remote host. We will do it by docker load, and then we'll specify the file name, and we'll run it, and that's it. If we do docker images now, we can in fact see that we have moved the image from one host to the other. Okay, so let's just see how we can easily again do the very same thing that we did on my local machine, but on remote host. I will do docker run. We'll run it in the background. We will map the ports, again 3000 of the host to 3000 of the application. We're running my micro 0.4, and that's it. It's running. We can do docker ps to see that we have a container running. We can run docker machine IP DigitalOcean to see which IP we should use to access it in the browser. This is the IP. Let's copy, move back to the browser, have it here, port 3000. Here it works. Very easy, very simple. We have it running on DigitalOcean. We can do the same on any other cloud provider. Okay, That's it for today. Again, we will be sending the link to the recording to everyone who sign up on the meetup. Also going to be uploading, we haven't done it so, but I will upload both the slides of today's meetup as well as the previous meetup to blog.codefresh.io. We invite you to sign up to the Containers One-on-One meetup so you can attend the future meetups that we will set. And again, we also encourage you to sign up for the Docker online meetup, which is delivered by Docker. And in fact, the next one will take place tomorrow with Docker talking about the new toolbox. Lastly, if you have any questions, you may send me or to Raziel at codefresh.io. You may visit us at www.codefresh.io as well. Again, beta is now open, so you may welcome to try it out as well. Connect Codefresh to your GitHub or Bitbucket and see how you can very fast create Docker images and run them. That's it for today. Thank you everyone and have a great week.